So the piecewise defined function that we're going to look at here, when I get ready to graph it, I'm going to actually graph each piece first. So in other words, let's take a look at y equal negative 2x. Now, we know that's a line with negative slope. When x is negative 1, y is 2. When x is negative 2, y is 4. When x is negative 3, y is 6. And then when x is 1, y is negative 2. When x is 2, y is negative 4. And when x is 3, y is negative 6. And so we're going to connect our dots here. And so that, of course, is the graph y equal negative 2x. Now we'll look at the graph of y equal x squared, our friend the parabola. And so we know that 0 squared is 0, 1 squared is 1, 2 squared is 4, negative 1 squared is 1, negative 2 squared is 4, 1, 2, 3, 1, 2, 3, 4. 1, 2, 3. I needed that up one, didn't we? There we go. There we go. And so we can connect those dots, and we see that we have our friend the parabola. And then we know that our third piece here, our third piece is this line y equal negative 2, and that is indeed this horizontal line. Now, when we get ready to graph the piecewise function, I'll graph that in yellow so that it'll be maybe a little easier to see. If x is less than negative 1, we are on this line y equal negative 2x. So less than negative 1, let's start here. Now this is an open circle at negative 1, and we're going to shade to the left. Okay. And at negative 1, now let's be careful here. Let's be careful. I went a little too far there. Went a little too far, so let's try to fix this here. There we are. So when x is negative 1, we know that y is 2. Alright, so there's that part of the graph. And then, if x is between negative 1 and 1, so this is where we get to include, we've got a closed dot here, and we go over here at 1 to our open dot. Alright. And then if x is greater than or equal to 1, well, that takes over right here. It takes over right here. And we'll shade in. If this little guy will go away, we'll shade in. So what I've drawn in yellow is actually the graph of f of x. Okay? All those pieces together make up the graph of f of x. And that's why we call it a piecewise defined function. Now, let's get ready to look at a function that may very well be totally brand new to you, and that is the greatest integer function. If x is a real number, we define this symbol as follows. The greatest integer of x equals n, where n is the greatest integer such that n is less than or equal to x. So let's think about a couple things here first, and I'm going to start out by looking at a number line because I think that will be perhaps the easiest thing for us to do. The number line here, let's go back and get my black ink. Here we go. Here's 0, 1, 2, negative 1, negative 2. So if I have the greatest integer, let's say, of 0.7, Now here's 0.7 on a number line right here. The greatest integer less than or equal to 0.7 is 0. If I have the greatest integer of 1.2, here's 1.2 on a number line. The greatest integer less than or equal to 1.2 is 1. Looking over here at the, let's say I have the greatest integer function of negative 1.7. Alright, now here's negative 1.7. The greatest integer less than or equal to negative 1.7 is negative 2. Okay, and let's now look at the greatest integer less than or equal to negative 1. Well, the greatest integer less than or equal to negative 1 is negative 1. So hopefully those few examples there will make it a little easier to understand what the greatest integer is. And you can see some more examples here. You can graph those out for you. Little mention here of how you can do this on the TI-8384. I'm going to be real honest, folks. This is not a function that we graph all that much, and so I'm not going to worry about this. But we will take a look at just a couple graphs here. Alright. Now, before we start graphing these greatest integer functions with shifts on them and stretches, I'd like to take a look in black at y equals the greatest integer of x. Okay? And you know what? Black may not be the best color choice here. Let's go with red. And then I will fill the shifts in another color here. Alright, so y equal the greatest integer function of x. So this graph is going to look like so. Notice for all of these x's, the output is going to be right here. For all of these x's, the output's going to be here. For all of these x's, the output's going to be here. Alright, so we get an idea of, hopefully anyway, of what this greatest integer function is going to look like. Again, here we are at x equal negative 1, negative 2, negative 3. Let's say if x equal negative 2.5, the greatest integer, here we are, x equal negative 2.5, the greatest integer less than or equal to negative 2.5 is negative 3. Alright, so now we will look up here and we'll make use of our shifts that we talked about earlier. This is the greatest integer of x plus 2. Well, folks, this is going to shift our graph to the left. So this will be in blue. Notice every point is moved to the left. We sometimes call this function the step function for reasons that might be obvious. It looks like a bunch of stair steps here. Okay? So there we go. There we go. There is f of x equal the greatest integer of x plus 2. Let's move on to part B here, and once again allow me to draw in y equal the greatest integer of x, because I really think if we draw that in first, it makes drawing the graph with the shifts that much easier. Of course, if you're going to draw this in on your homework first, please make sure that you're using a different color and make sure I know which color I'm supposed to be looking at when I grade. Notice here, the greatest integer of x plus 2, this is going to take this graph and it's going to shift everything up 2 units. Okay, everything up 2 units. Alright. Now let's take a look at part C, and one more time before we even consider part C, let me draw in the greatest integer function here in red once more. Alright, and now notice what we're doing each time. We're actually multiplying the y value by 1/2. Alright, so we're going to take each of these y values that we have here, we're going to multiply by 1/2. So in other words, of course 0, 1/2 of 0 is still 0, but the greatest integer here, alright, this only goes up about 1/2, and this is only 1/2 of what we had before, so half of 2 is 1. Alright, likewise 1/2 of -1 is -1/2. So certainly this may be a little difficult to see with a smaller scale, and I'll be honest, I'm not going to do a whole lot with this on exams or anything like that, but certainly feel free to ask me to talk about this in class if you're a little unsure of how the graph of the greatest integer function works. Let's look at part D here one more time. Let's for reference, let's draw in the greatest integer of x. So we're getting an idea of what this stair-step function looks like. Now, you'll remember that when we multiply the input by a value between 0 and 1, that's actually a horizontal stretch. That's actually a horizontal stretch. And so what you're going to notice this time is that all of these y values, alright, or all these x values rather, will be actually stretched out. So this is going to go from here over to here, from here over to here, from here. You can see the stretching going on. Same thing is true when we get down here. This will stretch out factor of 2 over this way, stretch out a factor of 2, and so hopefully you can see the blue. I didn't give us any of these for class discussion. There's a couple to look at here in the homework. Again, just kind of think about them, go through. Certainly if you have questions, by all means, please bring them up. And of course, we'll finish off here with our traditional word problem at the end. Question about property tax rates. A certain state taxes the first $600,000 in property value at a rate of 1%. All value over $600,000 is taxed at 1.25%. Find a piecewise defined function t that specifies the total tax on a property valued at X dollars. Well, here we go. We've got our function t of x, so our input is going to be x, and my tax rate is 1% if x is less than or equal to 600,000. And then if we go over 600,000, well, then our tax rate becomes, and of course we're going to look at what we have to pay already. We've got 1% of the first 600,000 plus, now 1.25% for everything over that. Well, 1.25%, folks, in a decimal is 0.0125, and then my income is x minus $600,000 because it's 1.25% on anything above the $600,000. So there we go, and I'm okay if well, we need to write if x is greater than $600,000, and for the purposes of this problem, then we'll go ahead and simplify this. T of x equals 0.01x if And I need 0 there. Not going to make any sense if we make negative money. 0 less than or equal to x less than or equal to 600,000. And then when we simplify this line here, we get 0.0125x minus 1,500. And that is if x is greater than $600,000. Alright, again, no class discussion problems to look at here, but for homework, please take a look at problems 67 and 69, and this concludes our lesson on 2.5.